Hello, this is Mrs. Huntley. This is the second video in the Pythagorean Theorem unit. This is titled the Pythagorean Theorem, so we're going to introduce you to what the Pythagorean Theorem is. I realized we don't have page numbers, so what I would like you to do is add some page numbers so when I'm referring to a page number, it makes sense which page you're going to go to. So start on the page that says Pacing Guide and just add the number 1 at the bottom. So then when you go to the next page, which is actually where we're going to start today, that would be page number 2, and so on. So if you wouldn't mind pausing the video right now and just adding page numbers to the bottom of each page. So this is going to be page 3, and then moving on, let's see, the one that says the Pythagorean Theorem homework at the top is going to be page 4. So you can go ahead and pause the video and keep adding page numbers to the bottom of the page, just so when I refer to a page number, you know what I'm talking about. Okay, going back to the page, if you need to pause the video, that's fine. Going back to the page that we're going to start on, actually that's going to be page 2, so it's the page after the pacing guide. And we have some fill-in-the-blank notes at the top. So it says, in a right triangle, the two sides adjacent to the right angle, adjacent means right next to. So if I'm looking at this right triangle here that's on the side, the legs are the ones that are next to or that have the right triangle or the right angle inside. And the right angle is always shown by having this little box in the corner. So I'm going to highlight those super quick for you so you know which ones we're talking about. So this is a leg, and this is a leg, okay? So in a right triangle, the two sides adjacent to the right angle are known as the legs, and I've highlighted those legs for you. I'm going to go ahead and label as well my drawing. So this is a leg, and this is a leg. I don't know where that stray mark came from. Try to get rid of it. There we go. So those are my two legs. Now, when I'm labeling them, because I'm going to be using the Pythagorean theorem to figure out missing sides. So when I'm labeling them, they're going to be my A and my B side. Now, it does not matter which leg is A and which leg is B. Okay, so I could have just as easily said that this one was A and this one was B. My legs are interchangeable. It does not matter which one I say is A and which one I say is B. The side that's opposite the right angle, when we say opposite, we mean if we draw a line through that right angle, it's going to be opposite. That's the one that matters. And that one is the hypotenuse, and that is always our C side. So the arrow is always going to point to C, and this is our hypotenuse. Hypotenuse might be a new word for some of you. Maybe you've not heard that word before, but the hypotenuse is always the longest side of a right triangle. So if you're just given numbers and you say, and it's a problem, I think we might have one of these coming up where they say one side of the triangle is 5 centimeters, the other side is 4 centimeters, and the third side is 8 centimeters. Which one is the hypotenuse? You'd pick the largest one, so that the 8 would be the hypotenuse. Okay? So the Pythagorean theorem tells us how the side lengths of the right triangle are related. It says in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. More simply stated, we're going to use the formula that says a squared plus b squared equals c squared. And I'm going to explain to you what that means. Now it makes sense why we did that square root table, doesn't it? We can use our calculator in this part of the module, but it's so much easier if you are very familiar with the squares and you've memorized them, and you're very familiar with them, not only for this part of math, but for algebra as well. You're going to be using squares and square roots probably from this time on in math, okay? So first they want to just make sure that we know which is our A side, which is our B side, and which is our C side. Again, the only one that really matters is being able to identify the C side. So if I draw an arrow through that right corner, it's always going to point to C. Then my A and my B are interchangeable. I'm going to show you one more time, and then I'm going to ask you to pause the video and label up the last two. So I've got my right angle is depicted by this box here. So I know that's my right angle. I'm going to draw an arrow through it. It's always going to point at my C side. And then I can just label up A and B. Please pause the video right now and label the last two triangles here. Please pause the video and label the last two triangles. Draw an arrow through my right triangle. It's always going to point to C. I should say when I'm drawing that arrow, I'm drawing through the box and it's always pointing away from the box. And again, my A and my B side are interchangeable. If you had them opposite the way I just put them, that's okay. In fact, I can change it right now so you feel comfortable. This could be A and this could be B. This could be A and this could be B. I don't remember how I had it before, if I'm being completely honest with you. Get rid of these stray marks so you don't think that you need to copy them. And let's move down. It says, use the Pythagorean theorem to find the missing side length in each right triangle. Round to the nearest tenth if necessary. So we're going to be using our calculators. And I'm just going to write the formula up here. A squared plus B squared equals C squared. This looks like it's going to be my right angle. There's no box in it, so I don't know that it's a right angle right now, but I'm assuming that the one that looks like a right angle is going to be my right angle, and I'm going to say it's pointing at my C side. So when I set this up, I'm going to label A and B. And again, they're interchangeable, so it doesn't matter if you switched it around the other way. Get rid of that real quick. So let's set this up. 3 squared plus 4 squared should equal C squared. So 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16, should equal C squared. 9 plus 16 is 25, so 25 equals C squared. Now, I don't really want C squared, I just want plain old C. I want to know how long C is. So I'm going to take the square root of C squared and the square root of 25. Square root of 25, if you don't know it, you can check your square root table, or you could do it on your calculator. Either way, the square root of 25 is 5. And the square root of C squared is just C. So C equals 5. So I could label this up here, 5 inches. Does that make sense how I did that? Okay, again here, this looks like it's my right angle. It's going to point at my C side. The reason I'm taking the time to identify which is the C side is because eventually we're going to have a problem where we've got the C side and we're looking for one of the legs. So I can set this up as 7, let's go ahead and label A and B. So 7 squared plus 24 squared equals my C squared. Oops, I forgot the 2. 7 squared is 49. Ooh, 24 squared never made it to our table because I only went up to 22. So I'm going to grab the calculator really quick. 24 squared is 576. Okay, 576 plus 49 is 625. I'm going to take the square root of C squared because I just want plain old C, and the square root of 625. So C is going to equal 25. Ooh, I knew that one off the top of my head. Okay, so this one should be 25 centimeters. Okay, the next one. Go ahead and pause the video and see if you can set this next one up without me. Go ahead, pause the video, see if you can get it set up. Don't just copy from me. You've got to try. Okay, 7 squared plus 12 squared equals c squared. 7 squared is 49. 12 squared is 144 equals c squared. 49 plus 144 is 193 equals c squared. 193 is not going to be on our square root table because it is not a perfect square. So I just want to show you super quick on the calculator how to find a square root. So I think I might have shown you this before, but here is the square button. You see right on top of it, that little purple up there, it's like a little radical sign. So if I do second that button, I get that radical sign there. And then I can punch in 193, enter, and I'll get 13.89244, and it goes on. So let's look at my directions again. My directions tell me to round to the nearest tenth if necessary. So the square root of 193 and the square root of c squared, so c is going to equal 13.9. And these are feet. Okay? Let's move on to the next page. Okay, I told you they were coming, where we're not going to have a leg. Because if you look, this looks like my right angle. And it's pointing to the C side, so I've already got the C side labeled here. So if this is A and this is B, I'm missing the B side. So I can say 5 squared plus B squared equals 13 squared. And this is just problem solving. I know you did this a lot in 7th grade where you had equations to solve. You probably didn't have the squares and the square roots, but it's not that much of a stretch, I don't think. Okay, so 5 squared is 25. We don't know what b squared is yet. We're going to have to figure that out. And then 13 squared is 169. Okay? So now how do I get the b all by itself? We were talking a little bit yesterday about opposite operations. So I've got a positive 25 there. The way I can remove a positive 25 from the left side of my equation is by subtracting 25. And hopefully you remember, whatever you do to one side of the equation, you've got to do to the other side of the equation. So I'm going to have b squared equals, well, I should say 25 minus 25 is 0. So that zeroes out. I don't have to write the 0 because I've got something else on this side of the equation. Then I've got 169 minus 25, and that's going to be 144. Now I can take the square root of both sides of the equation. So the square root of b squared is just going to be b. The square root of 144 is going to be 12. Again, I know most of my squares off the top of my head. I get a little bit fuzzy past 15, and I'll look at a number and go, oh, I think that's a perfect square. But for most of my squares up to 15, I know them right off the top of my head, and I'm hoping that you will get there too, because truly, I tell you, it will make your life a lot easier. So the next one, again, this is my right angle. It's pointing to the C side. What I'd like for you to do right now is pause the video and see if you can get the equation set up without me. Pause it. Don't just copy. Okay, again, if you labeled the opposite, if you said that the 6-yard side was A and the other side was B, That's fine. You're going to get the same answer. We're looking for the missing leg, and they are interchangeable. It really does not matter which one you label as A and which one you label as B. Okay, so A squared plus 6 squared is 36 equals 100. See if you can solve the rest of the equation from here without me. Subtract 36 from both sides of the equation. A squared equals 64. Square root of A squared is just plain A. Square root of 64 is 8. These are yards, so I would label this 8 yards. Okay, go ahead and see if you can get the next one set up. Pause the video, see if you can get it set up. Okay, 16 squared is 256. Again, we don't have 24 squared on our table. I guess I should have made my table bigger. I probably should have gone all the way up to 25. Okay, 320. Now 320, again, is not going to be on our square root table because it is not a perfect square. So you're going to have to grab a calculator and you're going to have to do that second square root button and punch in 320. And you should get 17.88854, and it goes on. So the square root of b squared is just plain old b. Square root of 321 is 17.888. So we're actually approximating it when we round it. So if I'm going to say it's 17.9, that's an approximation, and we really should use these little squiggly equal signs because we're saying it's about 17.9. And what we're going to learn in the next part of this module is that the square roots of non-perfect squares are actually something called irrational numbers. And we can't pinpoint the exact value of an irrational number. We can only estimate it. So that's why those squiggly equal signs come in handy. Okay, we have a couple of application problems here, and I'm running kind of tight on time because I'm already at almost 18 minutes. So I'm going to get in at least, I'm going to set up I'm going to set up the application problems. We may not get them worked out completely, but we'll go ahead and set them up for you and see if maybe you can work them out on your own, or we'll go over them in class together. Number 7 says a rectangular pool at Andy's gym measures 25 meters by 50 meters. Now, I love drawing pictures for my story problems. It helps me visualize things. I think I shared with you I'm a very visual learner. So if I've got 25 meters and I've got 50 meters, how many meters would Andy need to swim in order to swim diagonally across the pool? So we're going to swim diagonally here. Well, when I have a rectangle, I've got my right angle there. So it's pointing at the C side of this right triangle. So I can use the Pythagorean theorem to find out how far it is diagonally across that pool. I'm not going to do the problem any farther than that. You should be able to set it up. A squared plus b squared equals c squared. Number 8 says a pole vaulter rested a 17-foot pole against a wall. If the top of the pole hit the wall 14 feet above the ground, how far from the wall is the bottom of the pole? So let's think about this. Here's my wall. Here's the ground. There's my right angle, right? The pole vaulter rested a 17-foot pole against the ground. So he's running up. He's coming here and he's running up, and he plants his pole here, and it's resting against the wall. What do we have there but the hypotenuse of my right triangle? So that's 17. Here's my 14, and I'm missing this side over here. We'll call it A. So see if you can, again, use the Pythagorean theorem to figure out how long that pole is. Now these last two are pictures of what you will see when we're talking about a proof of the Pythagorean theorem, and I see that I just turned 20 minutes. So what I'm going to do is I'm going to stop. I'm going to stop the video right here, and we will do these last two problems in class, and we'll go over the correct answers for these two here. I hope you have a great night, and I will see you tomorrow.